So the first half of question 10 is about difference equations. So there's basically this population of grasshoppers, and they know a little bit about the population. So it's going to increase by a factor of 1.2 each month, but the entomologist removes 30 grasshoppers, so they remove 30 from the population each month to carry out research on them. And then the last important piece of information is that at the start of the first month they have 175 grasshoppers, so U0 is 175. Now they ask you to write down a difference equation to express this in part 2, but I think that's easier to do part 1, so I'm going to do that first. So we're going to have un plus 1, that's going to be equal to, well, we know that it increases by 1.2 each month, so we're going to have 1.2 of un, so what was the previous month, and then they take out 30, so it's going to be minus 30. Now, technically, it kind of matters if they took the grasshoppers out at the start of the month or the end of the month, because if they took it out at the start of the month, then the 1.2 would apply to both of these things, kind of like this. But I tried doing it that way, and it doesn't quite work out. It ends up with negative numbers, which doesn't really make sense. So we assume that they take the grasshoppers out at the end of each month, and you'll see why in a second. So now, if we calculate U1 and U2, well, U1 will be equal to 1.2 times U0 minus 30. That's just equal to 1.2 times 175 minus 30. That's equal to 180. Now, if we calculate U2, that's going to be 1.2 times 180, because 180 is the previous one, minus the 30, and that's going to be equal to 186. So you can see in the first month it increased by 5, and in the second month it increased by 6. So the reason they couldn't take the grasshoppers out at the start is because if you do that and you do this, you'll see that 1.2 times 30 is 36. So what happens is this number here, the 180, it actually goes down, which means the population is decreasing. And eventually, once you go on long enough, it actually starts to get negative. And then obviously you can't have a negative population. So that confirms that indeed we do write it like this. We assume that they take it out at the end of each month. So that's parts 1 and 2 done. In part 3, we're instructed to solve the difference equation. Now, I know the method to solve a first order difference equation is different, but what I like to treat them like a second order inhomogeneous difference equation, and it's the same method as that, so you kind of get a one size fits all method, and I think that's best. So the first thing we do is we figure out the complementary solution, and that's going to be x equals 1.2, because we're replacing that un with just nothing, and then we're replacing the next one up with an x, and then if there was another next one up, that'd be x squared, and so on. That's just the same method as the inhomogeneous second order difference equations. So that means that un and our complementary solution, so I write a c there to denote that, that's going to be equal to a times 1.2 to the n, but we can't figure out what a is until we figure out the particular solution. Now, since we see there's just a constant, we can guess that the form of un is just equal to some constant which we'll call b, since we've already used a. That means that un plus 1 will just be b as well, because there's no n's changing, it's just going to still be the b. So now we sub those into our original difference equation, so replace the un plus 1 with a b equals 1.2, the un is also a b, minus 30. That means that minus 0.2b is minus 30, which means that b equals 150. So now we know that our particular solution, which we can write like this, equals 150. Now remember, to find out the final solution, what we do is we add them both together. So un will be a times 1.2 to the n plus 150. Now I also know that u0 is 175, so we can sub that in. So u0 will be equal to a times 1.2 to the 0 plus 150. And u0 is also equal to 175. So that gives us that a is just 25. So that means our final solution, un will be 25 times 1.2 to the n plus 150. And that's it. That's our solved difference equation. So in the final part of part A, we're asked to calculate u12, which is the number of grasshoppers after a year. Because remember, each n represents 1 month, 12 months is a year. So u12, that'll be equal to 25 times 1.2 to the power of 12 plus 150. And if you put that into your calculator, you got 372.9. And then obviously you can't have 0.9 of a grasshopper, so I'll round it down and say that's 372 grasshoppers. And that's the final answer. So part B is a very interesting circular motion question. So there's this toy car going around a vertical loop, so it's an example of vertical circular motion. So point A is the very bottom, and at that point its velocity u will be the square root of kgr, where r is the radius, g is acceleration due to gravity, and k is a constant. And we're ignoring friction. So now in part 1, we have to draw a diagram showing the forces acting on the car when the radius to the car makes an angle theta with the upward vertical. So we'll say this rectangle is the car, and I've drawn in a bit of the circle as well just to show that. So obviously it's going to have the weight pulling it down. and the weight will be equal to mg. And then, of course, we're going to have a reaction force because it's touching the loop, and that's going to be perpendicular to the loop, so it's going to be going this way. That's going to be the reaction force. Now, since the centripetal force is going to point towards the center of the circle, which is here, we should really resolve this weight force to point in the same direction as the centripetal acceleration. So how do we do that? Well, I'll draw a separate diagram. So as you can see up there, we have this, the angle theta, and then we have mg going straight down. And now hopefully you can see it. So we have alternating angles here. So this one is alternating with this one. So that means that this angle is also theta. Therefore, this is mg cos theta, and this is mg sine theta. And they're all the forces acting on the car. Now we're told that the car loses contact with the track when this angle theta is made. And then we're asked to show that cos theta is k minus 2 over 3. Well, we have to use a few facts here. Number one is that the centripetal force, so we'll write Fc, that's going to be equal to, well, since we know what u is, the initial velocity, we can write it as mv squared over r. So that's going to be the sum of forces pointing towards the center of the circle. So you can see in our diagram we have the reaction force. Then since the weight is going in the same direction, we do plus mg cos theta, because they're both going towards the center of the circle. That's our first equation. Our second fact is that because it's losing contact, there's going to be no reaction force, or is going to be equal to 0. Therefore, if we have no or here, we just have mv squared over or equals mg cos theta. So we can divide by m on both sides, and we know that v squared over or will be equal to g cos theta. Now the next thing we need to do is we need to get rid of that v squared. So how do we do that? Well, we can use the conservation of energy. So the initial potential energy plus the initial kinetic energy will be equal to the final potential energy plus the final kinetic energy. So the main problem is we don't know what the final height is, so we're going to have to go back to our diagram to figure that out. So if we have a look here, this is the point we're trying to find, right here. So how can we find that? Well, if we just dot across, we need to find this point here. So you can see we have a little right angled triangle there, so we can draw that out. So we can see this is or, this is the radius from the center to the point, and this is the little height that we have. We'll call it h for now. So we can see that h will be equal to or cos theta, just because of trigonometry. So the height is going to be this h, which is this part, that's h, plus this part here. And what's that? Well, that's just a radius of the circle, that's just or. So that means that h1, the final height, is going to be or plus or cos theta, which you can also write as or times 1 plus cos theta. So it starts at the bottom of the loop, so we can, h0 is just 0, so this entire term is going to be gone. And we're going to have m, and we're told that u is the square root of kg or, so u squared is just kg or. So we can have m kg or all over 2. That's going to be equal to mg, and h1 we calculated, remember, to be or times 1 plus cos theta plus mv squared over 2. So we can cancel out these m's, and we can multiply by 2 just to simplify a bit. So I'll get the kg or equals, we're going to have g or times 1 plus cos theta. So it's going to be 2g or, because we multiplied by 2, remember, plus v squared. Now, in our equation up here, the v squared is what's causing the problem. So if we solve for v squared, we can say that v squared equals or g cos theta. We can put this v squared in place of this v squared. So we can write that kg or equals 2g or times 1 plus cos theta plus or g cos theta, because that's the same as v squared. Lots of things cancel, that g or, that g or, that g or, and we get that k equals 2 times 1 plus cos theta plus cos theta. Now we just have to solve for cos theta, so let's say that k equals 2 plus 2 cos theta plus cos theta. Therefore, k minus 2 all over 3, that's going to be cos theta, and that's exactly what we were asked to prove in the question. So in the last part, we're asked to calculate the minimum value of k such that the car successfully completes the loop without losing contact with the track. So we know that when it loses contact, this equation is true. And if we have a think about it, what point on this diagram does the car have to get to ensure that it's going to finish? Well, if it can get to the very tippy top here, then once it goes past that, like here for example, it's going to be moving down, and the gravity's pulling it down anyway, so once it gets past this point, the very top point, then you know it's going to finish the loop. So that top point is when theta equals 0. So when theta equals 0, k minus 2 over 3 equals cos of 0. Cos of 0 is just 1. That means that k minus 2 is equal to 3. That means that k equals 5. So basically that means if k is 5, it will lose contact at the very top. So technically k should be a tiny bit bigger than 5, but because it has to only be a tiny incy-wincy bit, we can just write 5. And we know that because as k gets bigger, we know that u equals kg, or so as k gets bigger, its velocity is bigger. So that means that a bigger value of k will mean a bigger velocity. So yeah, a tiny bit bigger than 5 is the answer, but we can just write k equals 5.